Hello, everyone. In this video, let me briefly share something about the 2025 AMC10A test. I just did this test, and here are some observations. First, I feel that this test focuses more on sequences, polynomials, and probability. Like there are four questions on sequence and three on polynomials. I think that's more than past years. Also, there are three questions on probability. Maybe that's more normal. And the test seems to be harder, especially when I do the first 10 problems. I think they are harder than the past AMC10 test. The first 10 problems that they used to be very easy or pretty easy, but this year the 10 problems are harder, especially some questions required some algebraic techniques to manage the numbers, the formulas. Yeah, and yeah, that's what I mean. It requires more solid skills in computation algebra, especially yeah, for even for the beginning questions. Okay, here are some mild suggestions. So if you are preparing for the next test, do not expect the first 10 problems to be very easy. Be prepared to apply some medium or advanced algebraic skills to solve the first problems. The second one is my personal suggestion. I kind of feel that the problems are more like Amy questions. Of course, Amy is much harder, but the styles, the structures seems to be similar to Amy questions. So probably it will be helpful if you go to practice some past Amy problems, especially question 1 to question 5. Um, I think that might be helpful for your next test. Okay, in the next part of the video, I'm going to do a few problems from this AMS10A test. Hopefully that give you some um, ideas and some help for the next test. All right, let's work on question 9. F is a polynomial given here. It's a cubic polynomial. For how many real numbers A does the graph of f of x minus a passes through the point 125? So when I see the polynomial, my first attempt is to factorize it. So here, let's factorize it. Especially we can first factor the 100, right? The coefficients are all multiples of 100. So it's 100 times x cubed minus 3 x squared plus x. Of course, we can also factor the x. So 100x, x squared minus 3x. Oh, I missed this 2. 2x. Right. So then it's easy to factorize this parenthesis part. It's 100x times x minus 1, x minus 2. Right. The question is asking how many a's. So if you shift the graph by a, it passes through 125. So 125 is on y equals f of x minus a. That just means we have a 25 equals y and x equals 1. So this equation holds. Essentially, we're going to solve this equation. How many a's, how many solutions are there for this equation, right? Let's plug in 1 minus a to the above expression. 25, okay, replace all x by 1 minus a, 100, okay, 1 minus a. Here, x minus 1, okay, 1 minus a minus 1 is minus a. And x minus 2 is minus 1 minus a. Yeah, we basically get that equation. So, yeah, let's divide by 25 very well. If you divide by 25, you have 1 equals 4, 1 minus a, negative a, negative 1 minus a. Yeah, let's put a negative sign to each parentheses. So I'm going to have minus 1 equals 4, a minus 1, a plus 1. right? That's my preference. I would like the leading term to be positive. Okay, so basically we're going to solve this equation. If I divide by 4, I have a negative 1 over 4 equals the a part is a cubed minus a, right? How many solutions? How many solutions? How many real number a are there? That's the question. Question, how many a? Right. Um, so my approach is to try to graph try to graph a function which is, let's say, x cubed minus x minus x. So again, factorization. Yeah, factorization. This gives you x minus 1, x plus 1. It tells me that there are 3 roots, right? 3 roots. First, we have the root 0. 0 is the root, right? This is x, this is y. 0 is the root, 1 is the root, minus 1 is the root. Minus 1 is the root, 1 is the root. It has 3 roots, this polynomial. Because when x is big and when x is larger than 1, you can tell when x is larger than 1, everything is positive, 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 positive. So when x is larger than 1, it's positive. When x is yeah, let me write it down here. When x is larger than 1, x minus 1, x plus 1 is positive. When x is between 1 and 0, x plus 1, that's less than 0. So the graph looks like this. And when x is between minus 1 and 0, we can see that x times x minus 1, x plus 1 as negative here, and plus here. So it's positive. And when x is less than minus 1, this is a negative. So roughly, the graph is something like that. Okay, that's the graph. Yeah. Also that we notice that this equation is a cubic polynomial equation. It has at most 3 solutions. This is degree 3. There are at most 3 solutions. You can tell that if x go to very, very negative, the polynomial go to very, very negative. So how to solve the equation? The equation, that means we draw a line y equals minus 1/4, right? This polynomial is y equals x cubed minus x. We're going to see how many solutions for the above equation here. So we set y equals negative 1/4. Maybe here. Y equals negative 1/4 and see how many intersections. The problem is that we don't know how small this value is, right? We don't know. So maybe the 1/4, negative 1/4 is here. That means we have only one intersection. If negative 1/4 is above this minimum point, we're going to have 3 intersections. Okay, so that's some estimation. So let's see. Is this minimum value smaller than negative 1/4? If some of you learn calculus, you have a very systematic skills to solve it, but this is AMC10A. We don't really require a calculus. So here, let me apply some skills of estimation to determine that. For those of you who know calculus, you can apply calculus like derivative. But let me do the estimation skill here. So what I do is try to just plug in a few points here. Let me see. Roughly, let me just apply the point half and see what's the value. If I apply the point half, if x equals half, y equals half cube minus half. So that's negative 3 over 8. And negative 3 over 8 is already smaller than negative 1 over 4. So I just pick a x to be half. And maybe there's some other point the y can be smaller. But my estimate is enough to determine the minimum point is below negative 1 over 4. So that means when I draw this blue line, y equals negative 1 over 4, there's going to be three intersections. Yeah, three intersections. Because this minimum point is smaller than negative 1 over 4. Therefore, we have three intersections. One's here, one's here, one's here. So two positive A, one negative A. Let's say A1, A2, A3. Yeah, we got three, and they are at most three. So the answer should be 3. The answer is 3. Okay, that's a question 9. Right. All right, next, let's do question 13. Here we have a square. Actually, we have a sequence of squares. The side lengths are in a ratio of k. We're going to solve k such that the shaded part takes totally 64%. All right, what is k? All right, for simplicity, let me just assume that the big square has side length 1. By the question, the next square should have side length k. Let me mark here k. And next one is k square. Okay, I should make smaller. K cube. And maybe next one is k fourth. Yeah, this is k fourth and k fifth, like that. So the shaded part takes 64%. What is k? Now we can find the expression of each shaded rings. Like first one, the first area. Let me put here. The first area is the difference of two consecutive squares. So the first square's area is 1 square minus k square. Now let's do second one. Second one, I mean this one. Second one, the area is the outer square's area minus the inner square's area. All right, let me just do one more. The third one, here's k fifths. Okay. The third one is k fourth square minus k fifths square. And I think that's enough to show the pattern. Okay, now let's see what's the sum. The sum should be 64%. Total shaded area. Total shaded area is equal to 1 minus k squared plus the second one is k to the fourth power minus k to the sixth power, and plus the third one is k to the eighth power minus k to the 10th power. So the exponents are all even numbers in the alternating way. And now for each later term, let me factor some k. Say here again, technically I can factor k to the fourth power, and it's 1 minus k squared. Third term, I can factor k to the eighth power, 1 minus k squared, and so on. So the common factor is 1 minus k squared. And then this is 1 plus k to the fourth power, k to the eighth power. Next term should be k to 12th power by this pattern. And that's geometric sequence, right? That's geometric sequence. And we know the summation formula for the geometric sequence. Here, because k is less than 1, between 0 and 1, so the common ratio k to the fourth power is also between 0 and 1. We have the summation formula is The sum is 1 over 1 minus its common ratio, k to the fourth power. Right, this is a sum. It equals 64%. And the next part is to manage the algebra and solve k. Right, here we have 1 minus k squared over 1 minus k to the fourth. Let's apply the difference of square formula. It's 1 minus k squared times 1 plus k squared equals 64%. So 64% is also equivalent to 16 over 25. I prefer fraction personally. Let me cancel out this 1 minus k squared. So cross multiplication implies that 25 equals 16, 1 plus k squared. And then we can solve k squared. K squared is equal to 9 over 16. Well, yeah, you can see k. K is a positive, so k has to be 3 over 4. So the answer should be 3 over 4. D, yes. All right, next, let's do problem 16. This is a probability question related to counting, um, but it's asked in terms of expectation. Okay, here we have 3 jars. Yeah, let me just draw 3 jars. Jar 1, jar 2, and jar 3. And we have 3 coins. Each of them is placed in one of the 3 jars chosen at random and independently of the placement of other coins. What's the expected number of coins in a jar with the most coins? So basically, we're solving the expected value of the maximum number of coins among these 3 jars. Let's first find how many ways to place the coins because each coin is free to be in any jar. So the total number should be 3 cubed. Total number of ways to place these coins is going to be the first coin has 3 options, jar 1, jar 2, jar 3. The second coin has 3 options, jar 1, jar 2, jar 3. Same for the third one. So by multiplication principle is 27. There are 27 ways to place the coins. That 27 is the denominator in the probability. Okay, next, let's discuss different scenarios to place the coins based on how many numbers, based on what's the distribution of these numbers. I'm going to discuss the first case. It will be the number of coins in each jar will be 1 plus 1 plus 1. Each jar has 1 coin. That's one scenario. Second case is that the number of coins in 3 jars is 0 plus 1 plus 2. In other words, we have 1 empty jar, right? Case 1 means we don't have any empty jar. Case 2 means we have 1 empty jar. And exactly 1 empty jar, that means the number must be 0 plus 1 plus 2. In the third case, we have 2 empty jars. That means we just have 0 plus 0 plus 3. And that's it, right? We have 3 scenarios. Now, let's discuss each case because this case will tell us what's the maximum number. Like case 1, the maximum number of coins is 1. Second one, the maximum number of coins is 2. Third one, the maximum number of coins is 3. So we need to find their probabilities and use that to solve the expectation. Okay, we discuss each case. Yeah. Okay, case 1. Let's do case 1. Case 1. Each jar has 1 coin. That's basically the permutation of 3 coins, right? Just permutation of 3 coins. The number of cases will be just 3 factorial, 6. So accordingly, the probability is 6 over 27. Now, case 2. Case 2, we have 0 plus 1 plus 2. That means we have to divide the 3 coins into 2 groups. One group has 1 coin and the other group has 2 coins. But there are different ways to divide it. Um, the point is that which coin is isolated, right? Which coin is isolated? And then that's three ways, right? Three, choose one or just three ways. If you know that isolated coin, you know which two coins are together. And after that, if you have this grouping, after grouping, we want to place the groups into three jars. So that's essentially also permutation. Like which jar has a zero? Three ways, right? Which jar has the only isolated coin? Two ways. And finally, the remaining jar takes that two coins group. So that's six ways. Right? So combining together, grouping process and the placing coins process, totally we have 3 times 6, 18 ways. For the second scenario, we have 18 ways, and accordingly, the probability is 18 over 27. On case three, we have all coins go to the same jar, so it's simple. Just determine which jar get it, right? Which jar takes all coins three ways, and the probability is 3 over 27. Yeah, maybe you should double check, like the sum of probability must be equal to 1. It is, right? 6 over 27 plus 18 over 27 plus 3 over 27, that's 1. So good. Now we can take the expectation. With probability 6 over 27, the max equal to 1. With probability of 18 over 27, the maximum is 2. With the 3 over 7 probability, the max is 3. So that's the formula to find the expectation. After simplification, we have this is 51 over 27. After simplification, you get a 17 over 9. So the answer should be 17 over 9. Yeah, which is D here. Question 17. Let n be the unique positive integers that divide such that dividing this big number by n leaves the remainder 16. That just means 2, 7, 3, 4, 3, 6. It's a multiple of n. Let's see q. Let's see q1 n multiple plus the remainder. Remainder is 16. Okay, remainder 16 actually implies n should be bigger than 16, right? On second one, if dividing the second number by n, the remainder is 15. So we have 2, 7, 2, 7, 60. It's q2 times n plus the remainder 15. That's what we know. And we're going to solve the unique positive integer n. Right, when I say this question, the first impression is that the number is very big. Okay, so typically the first one tells you, let me subtract 16. Let me just subtract 16. I will have 27, 34, 20. It's a multiple of n. So that give me the hint, n is a factor of this number. Similarly, for second one, I'm gonna have another one. Second one implies, let me subtract 15. So it's 2, 7, 2, 7, 45 is going to be q2 times n, right? That just implies n is a factor of 2, 7, 2, 7, 45. Now the question is reduced to find a common factor or common divisor of these two numbers. So it's very natural to just find the GCD of these two numbers. Find GCD of these two numbers. The only problem is that these numbers are big. Yeah. n must be a factor of the GCD, and also n should be bigger than 16. That's the requirement. Now, how do we find this factor? Um, the most basic way is to factorize both numbers. Well, it takes me a while to factorize these two numbers. Say the first number, 2, 7, 3, 4, 20. It's pretty easy. It's divisible by 4. So we have 2 squared. Also, it's divisible by 9 because the digital sum is divisible by 9. So this is pretty clear. Also divisible by 5. And later, you need to check it's divisible by 7. Actually, divisible by 7 squared. And the last one is 31. The second one seems to be slightly harder. 27, 27, 45. Again, it's divisible by 9 because the digital sum is 27, right? So it's divisible by 9. So 3 squared. Also, it's divisible by 5, but not 5 squared. And you can use divisibility test for 11. So it's divisible by 11. So we can factor 11. After dividing 11, you got to get a number. And this last two step is slightly harder. It turns out to be 19 times 29. Yeah. So, but that's the result of factorization. From here, you can get the GCD, right? GCD. The common factor should be 3 squared. That's common. 3 squared. Also, we have 5. And that's it. Yeah, we don't have more. So the GCD is 45. GCD is 45. Okay, now we know that n is the factor of both numbers, so n should be a factor of 45. 45 is 3 squared times 5. Now we also have n is bigger than 16, right? If you check all possible factors of 45 and it should be bigger than 16, the only possibility is just 45. N has to be just 45. And that's the n, the unique n. So the answer here should be 4. Should be 4. Of course, let me also share a way that's slightly easier. I'm not saying it's very easy, but slightly easy to do the GCD. Maybe it's helpful. Another it's maybe easier. Wait. So the fact is to use the Euclidean algorithm. Euclidean algorithm. Basically, if you have a GCD of two numbers, A and B, is equal to GCD of, say, let me subtract B from A, so A minus B, it's the same. Okay, that's the basic idea of Euclidean algorithm. Because here we have two numbers, they are big, but they are pretty close. So we can try this idea. So GCD 2, 7, 3, 4, 2, 0, 2, 7, 2, 7, 45. Now let's take a difference. All right, the first one is bigger. So the first one minus the second one. We have 2, 7, 3, 4, 20 minus 2, 7, 2, 7, 45 is equal to 675. So this is equal to GCD of 675, 2, 7, 2, 7, 45. It's much easier to factorize 675. That's pretty simple. So 675 is equal to 3 cubed times 5 squared. Now you just need to check what's the highest power 3, what's the highest power 5 in the second number, and then we find a GCD. Yeah, this is slightly easier. So we can easily check that 27, 27, and put it here. 27, 27, 45. First, it's divisible by 9. That's for sure, divisibility test. And it's not divisible by 27. It's not divisible by 27. You can easily tell, right? 45 is not divisible by 27. That's it. So the highest power of 3 is going to be just 3 squared, not 3 cubed. And also for 5, you can also quickly check. The common factor is 5, not 5 squared. Right? It's divisible by 5, very clear. But it's not divisible by 25. That's also pretty easy to check. So the GCD is 3 squared times 5, 45. And that's the part to find the GCD. which looks to be easier than the direct computation, direct way to factorize the numbers. So anyway, the answer is 4. Yeah, and it's 45. All right, finally, let me do question 22. We have these four circles tangent to each other, like the picture shows. We know the outer three circles have radii 1, 2, and 3. We need to find this small circle in the center. What's the radius? All right. 1, 2, 3 are very special numbers. If we connect the centers of these three circles, let me connect. Because they are tangent, it's very standard to just connect their centers. Let me just call it O1, O2, O3. Right? If you connect O1, O2, the distance should be the sum of radius is 1 is 2, so it's 3. If you connect O1, O3, it's 1 and 3. The O1, O3 equals 4. And if you connect O2, O3, this is 2 and 3. So, we can find a 3, 4, 5 triangle, right? 3, 4, 5 triangle. That means it's a right triangle. Yeah. And similarly, if you connect the centers to the center of the small circle, yeah, maybe let me go to O4, but I don't have space to write. Let me just connect this dot to this 3 centers. All right, so this is like R, little r plus 1. This is R plus 2, R plus 3, like that. So we're going to solve R. O1, O2 equals 3. O1, O3 equals 4. O2, O3 equals 5. That means we have triangle O1, O2, O3 is a, like, let me put it, 3, 4, 5 right triangle. Right triangle. Based on that, we have angle O2, O1, O3 is 90 degree. That gave me a hint. That gave me a hint to use coordinate geometry because I have right angles. I can set up the coordinate system. The origin chosen to be O1. So let me just use coordinate geometry to solve R. So let me just rotate it and set the origin at O1. Okay, here we go. X, Y. This is O1. And I have 3 here. That's O2. And O3 is supposed to be here. O3. Right? Oh, this is a 4. O1, O3 is 4. O1, O2 is 3. And O2, O3 is 5. Now we're going to let me assume the center of the small circle. The center of the small circle, let's call it just XY. It's in the coordinate system. And its radius, which is what we want to solve, its radius, let's call it R. Our goal is to solve R. And if you connect this point to these 3 vertices, like yeah, I want to call this O4. O4, O1 is equal to 1 plus R. And O4, O3, O4, O4, O2, that's equal to 2 plus R. 2 plus R. And O4, O3 is 3 plus R. This is the picture. And let's go to solve R. Let's go to solve R. Yeah, basically I just use distance formula. Say O1, O4 is equal to 1 plus R. That just means using distance formula, x minus 0, x squared plus y squared, right? Square root, that's the distance from O4 to O1 is equal to 1 plus R, which means, let me just squaring both sides. X squared plus y squared equals 1 plus R. square. I'm going to call this equation 1. I have two more equations based on the other two distances. I'm called O2 is equal to 2 plus r. Based on the distance formula, O2 has the coordinate 3, 0, 3, 0. So I have x minus 3 square plus y minus 0 square. So this taking square root, the distance equals 2 plus r, right? Let me square it as well. So x plus minus 3 square plus y square is 2 plus r square. I'm going to call this equation 2. Third, let's do O3, O4. O3, O4 is 3 plus r based on distance formula, because O3 has the coordinate 0, 4. 0, 4. So it's x squared plus y minus 4 square, taking square root, equals 3 plus r. Squaring both sides. We have x squared plus y minus 4 squared equals 3 plus r squared. Right, we have three equations. Equation 1 here. Equation 2 here. Equation 3 here. Let's solve r. We know they have a square, so I observed that each term has x squared plus y squared, maybe some other x, y terms. So the idea is to take a difference. If you take a difference, you will cancel out the square terms. For example, if I take a difference between equation 2 and equation 1, if I take a difference between equation 2 and equation 1, on the left-hand side, I will not have x squared, y squared anymore. So equation 2 expanded, ignore the x squared plus y squared, I have minus 6x plus 9. On the right-hand side, is 2 plus r squared minus 1 plus r squared. If you simplify, you don't have r squared anymore. R squared is canceled out, so we have 4r minus 2r is 2r plus 3. So you have minus 6x plus 9 equals 2r plus 3. Similarly, you can do 3 minus 1. If you do 3 minus 1, equation 3 minus 1, again, we don't have x squared and y squared on the left-hand side. I will have minus 8y plus 16. On the right, 3 plus r squared minus 1 plus r squared. If you simplify it, we have 6r minus 2r, 4r. 4r, 9 minus 1 is 8, so we have 8. So we have this equation. Now, based on that, because my goal is to solve r, let me just substitute x and y by r. Like the first one, I can solve x. I can solve x in terms of r. So if I remove it, so it's yeah, I'm gonna have 6x equal to 6 minus 2r, right? So x is 3 minus r over 3. 3 minus r over 3 in terms of r. Second one, similarly, if I rearrange it, I have 8y equals like 8 minus 4r. So that means I have a y equals, let me divide by 4, right? 2 minus r over 2. Okay, that's the xy in terms of r. Finally, we can just use the first equation, x squared plus y squared equals 1 plus r squared to solve r. X squared plus 1 y squared is 3 minus r over 3 square plus 2 minus r over 2 square equals 1 plus r squared. That's just a quadratic equation for r. That's just a quadratic equation of r. Yeah, when you expand it after simplification, like make the fraction into integers. So we're gonna have the following quadratic equation: 23r squared plus 132r minus 36 equal to 0. Yeah, it's not so obvious to factorize the terms, but it's doable. You can factorize that into r plus 6 and 23r minus 6 equal to 0. So you can solve r equals 6 over 23. So that's the radius, 6 over 23. Of course, you can use quadratic formula, but be careful in the computation. So you should have a solid skill to manage the algebra, the big numbers. So R is 6 over 23, B. Okay, that's basically the solution video for a few problems. I think overall the test is reasonable and there's no new math topics. And if you are solid in algebra, in computation, in yeah, I think you will be fine. Yeah, try your best for the next test. Yeah, I hope it will be much better for you next to do next test. Okay, yeah, good luck.